first question. Express 2020 as the product of its prime factors. So for that, we have to factorize 2120. First, let us take 2. Because it is an even number, it can be divided by 2. So it is 1. Then here we have a 1. It is not divisible by 2. So don't forget to put a 0 over here. Then this 1 is not divided, right? So 1 and 2 together. 12 is the next number we have to consider. So it is 6. Then a 0 is here. We have to put that 0 here. Don't forget to do this. Then again, it is a even number. It is an even number, so we can divide by 2 again. So it is 5, 3, 0. Again, divisible by 2. So it is 2 times 2, 4. So 1 is left from here. So 1 and 3 together, that is 13. So 6 times 2, 12. And again, 1 is left here. So 1 and 0, 10. So 5 times. See, this number is not divisible by 2 because it is not even. And 5 is there at the ones place, right? So it is understood that it is divisible by 5. So let us take 5 next. Then 5 times 5, 25. Then 1 is left here. So 15, it is 3. So 53. So only this much we can do, no? Because 53 is a prime number. We don't have any other factors for this given number. So we can write 2120 is equal to 2 into 2 into 2. See, 2 comes 3 times here. That is, we can write it as 2 raised to 3 into 5 comes once and 53 comes once. So 2 raised to 3 into 5 into 53. This is the answer. This is our second question. HCF and LCM of two numbers are 9 and 459 respectively. If one of the numbers is 27, find the other number. Okay, so we know the LCM and HCF of two numbers. Okay, listen, two numbers. Okay, LCM and HCF of two numbers. When we multiply them, we should get the product of the numbers. This is the theory over here. And LCM, HCF are given, right? Okay, so 9 into 459 is same as the product of those numbers. And one among the number is given as 27. So it is 27 into the unknown number. See here, one of the number is given as 27 and the other number is unknown. Let us take it as x. That is why it became like this. 27 into x is equal to this. So in order to get x, we have to take this 27 to the other side, right? So x is equal to, and here it is multiplication. The operation is multiplication. When we take it to the other side, it is division. So 9 into 459 divided by 27. Here we can cut the numbers, right? Because 9 is here and 27 here. We can cut them. 3 times 9 is 27 and 459. Is it divisible by 3? First, we have to check that. Yes, because the sum of the digits, 4 plus 5, 9, 9 plus 9, 18. So the sum of the digits is a multiple of 3 means it is divisible by 3. So let us divide by 3. Here, 1 time 3. Then 1 is left here, 15. So 5 times 3. So the other number is 153. This is our next question. The HCF of two numbers is 145 and LCM is 2175. If one of the numbers is 725, find the other number. See, the same logic we have to apply here. Here HCF is given as 145, 145 and LCM is given as 2175. So the product of this LCM and HCF, we need the product of numbers. And one of the number is given as 725. So the other we have to find, let us take it as x. Okay, in order to get the value of x, what we have to do, we have to move this 725 to the other side. Here it is multiplication. The operation is multiplication. When it's taken to the other side, we have to do division. So x is equal to 2175 into 145 divided by 725. Now, Numerator and denominator we can divide by 5. Here it is 2 times, and 2 times 5, 10. 4 is left, 45. So 9 times, 29. So here also we can divide by 5. Here 1 time 5, then 2 remainder 22. So 4 times 5, then again 2 remainder. So 25 5 times. Okay. Now 145. Here, see, we have another multiple of 5. So these two numbers we can again divide by 5. Okay, so here when we divide by 5 4 times, then 3 times, 3 times 5, 15. Here it was 17. So 2 is left, then again 5. Here when we divide by 5, we get, it is 2 times 5, 10, then 45, 9. See, 29 and 29, we can cancel, right? Okay, 29, 29 cancel. What is left? 435. So 435 is the other number. This is our next question. Find the LCM and HCF of 6 and 20 by prime factorization method. Do you know what is 6? 6 is actually 2 into 3 prime factors, and 20 is actually 2 into 2 into 5. When we make it into prime factors, we get 2 into 2 into 5 is same as 20. Now, to get the HCF, see, HCF means product of all the smallest power of each common prime factor in the numbers. So how many common prime factors are there for 6 and 20? See, prime factors are here. We know only one number is common for 6 and 20. See, 2. Only 2 is common there, right? And 2 comes only one time as common. So the HCF is 2 itself. Okay, so HCF is 2. Because it comes only once, and it comes only once as common for the given numbers. Okay. Now, LCM means the product of the greatest power of each prime factor. See here, when we compare the factors, no, 2 is here and 2 is here, but the greatest power happened here, right? 2 comes 2 times. So when taking the LCM, no, we have to take 2 raised to 2, because this is the highest power. And 3 is also there, but maximum 1, right? 3 2 times, not there, right? And like 5 is also there, only 1 time. So 2 raised to 2 into 3 into 5, that is the LCM. So it is 4 into 3 into 5. 2 square is 4. Now 4 into 5 is 20. So 20 into 3, that is 60 is the LCM. This is our next question. Find the HCF and LCM of 5, 10 and 92. Also verify that HCF into LCM is equal to product of two numbers. Okay, so 5, 10. See here, prime factorization is done. It is 2 into 5 into 3 into 17. It is written there. And 92 also done. The prime factorization 2 into 2 into 23. Now the HCF means highest common factor. So how many common factors are there for these two numbers? 2. 2 is there as common, right? Among these two numbers, 2 is common, and 2 comes only once as common, right? 2 comes only once as common. So it is HCF. Now LCM. We need LCM. LCM means the highest powers of all the factors we have to take, right? Least, common, multiple. Multiple means it should be bigger than the given numbers, or at least equal to or bigger than. Okay, so LCM means the highest powers of all the factors we have to consider. So here, see, 2 comes 2 times here, and here only 1 time. So we have to take 2 times 2, because highest powers are to be considered. Next is 3. Even if 3 is not here, no, in while calculating the LCM, we have to consider that 3. 5 also like that. 5 is not there in 92, but we have to take that as well. Then 17 we have to take, and this 23 also we have to take. That means we have to multiply each and every factor with its highest power. Okay, so when we multiply all these things, see, 2 into 2, 4. 4 into 5, 20. into 3 into 17 into 23. Okay, 20 into 3, that is 60. So 60 into 17 into 23, like that. When we do all the multiplications, no, we will get it as 2, 3, 4, 6, 0. So this is the HCF. This is our next question. Find the LCM and HCF of 60, 120, 288. See, we have done prime factorization. 60 is done here, 120 is done here, 288 is done here. So we can write 60 is equal to, see here, 2 into 2 into 3 into 5. So 2 into 2 into 3 into 5, that is 60. And similarly 120 is 2 into 2 into 2 into 3 into 5, right? 2 comes 3 times. 2 into 2 into 2 into 3 into 5. And 288 is 2 comes how many times? 1, 2, 3, 4, 5. 5 times 2. 1, 2, 3, 4, 5. And again 2 times 3. Okay. See, these are the prime factors of the given numbers. Now we have to take the HCF and LCM. Okay. HCF, highest common factor. See, it is obvious that 2 is there, right? For all the three numbers, 2 is there. 2 comes 2 times here. Here it is 3 times and here it is 5 times. So the highest common factor means 2 comes 2 times everywhere. So we can take 2 times. Now, 3 is also there, no? For all the numbers, 3 is there as the factor, but 5 is not there in this number, 288. 5 is not there, but 3 is there. So 1, 3. 1 times 3 appeared in all the numbers. So we can take 1, 3 as well. So this is the HCF. 2 into 2, 4. 4 into 3, 12. 12 is the HCF. Now comes LCM. So in order to get the LCM, no, we have to consider the highest power of all the factors. 2 is a factor, right? 2 is a factor of all the three numbers and the maximum power happened here. See, 2 comes 5 times. So we have to take 2 raised to 5 into. Next is 3. 3 is there, but the maximum power happened here, right? 3 raised to 2 is the maximum power for 3. Now, 5 is also there as a factor. The maximum power of 5 is 1 because 5 appeared only once in a number. Okay. So this is the LCM. Now 2 raised to 5. 2 we have to multiply 5 times. That is 32. 3 square, 3 into 3, 9. Then 5. Okay. So 5 into 32. Multiplying by 5 means just take the half of the number and just add a 0. So 32, half of 32 is 16 and then add a 0. So this is 32 into 5, then 9 into 9. So it is 1440. This is the next question. 3 bells toll at intervals of 9, 12, 15 minutes respectively. Okay. Then if they start tolling together, after what time will they next toll together? When will they toll together? Anyway, see 9 minutes, 12 minutes, 15 minutes. Will our answer be less than these? That is the first thing we have to think. Will our answer be less than these given numbers? No, because if it is less than the given numbers, the third bell won't toll at all because third bell will toll at 15 minutes. So at least 15 minutes should be there, right, to make them toll together. So that means we are searching for a number as the answer which is greater than or at least equal to the given numbers. That means we are searching for the LCM. Okay, if the answer logically, if the number or the thing which we are thinking is less than any of the given numbers, okay, less than the numbers means it is HCF. Now we are searching for a number which is greater than these three numbers. That means we are searching for the LCM. So as every time we do know 9, we have to do prime factorization. It is 3 into 3. Then 12, it is 2 into 2 into 3. Then 15, it is 3 into 5. So LCM means we have to consider the highest power of all factors. 2 is here. Okay, even if 2 is not here and here, 2 came here. So we have to consider that. We cannot skip that. So 2 raised to 2 is there in as a part of the LCM. Next is 3. 3 is everywhere, right? In all the three numbers, 3 is there as the factor, and highest power is 3 raised to 2. Then 5. 5 here. Only one time, maximum one time. So this is the LCM. 2 into 2, 4. 3 into 3, 9. And 5. So 4 into 5. First, let us do that. 4 into 5 is 20. 20 into 9. 9 into 2, 18. So it is 180 minutes. After 180 minutes, they'll talk together. This is the last question of our video. Sita takes 35 seconds to pack and label a box. For Ram, the same job takes 42 seconds, and for Geeta, it takes 28 seconds. If they all start the task together, after how many seconds will they be using the label machine together? That is, they are using a machine to label, right? And when they will use this label machine together, means we are searching for a number in seconds, right? The answer will be in seconds, a number which is greater than these given numbers, right? 35 is there, 42 is there, and 28 is there. So we are searching for a number which is greater than these three numbers. Then only we can say by that time all of them will need the same machine together, right? That means we are searching for a bigger number, means it is a multiple. That is LCM we are searching for. Okay, next our job is we have to factorize these numbers. 35 is 5 into 7, and 42 is 2 times 21, then 3 times 7, then 28, 2 times 14, then 2 times 7. Okay, so we can write 35 as 5 into 7, and 42 as 2 into 3 into 7, and 28 as 2 into 2 into 7. Now we need the LCM, no? So we have to consider each and every factor with its highest power. See, 2 is here. The maximum power is here, right? 2 comes 2 times. So 2 square into, next we have 3, and maximum power is 1 time, right? 3 happened only 1 time, and then 5 again 1 time, then 7 also 1 time. So this is the LCM. 2 square 4, 4 into 3 into 5 into 7. So let us do first this 4 into 5, that is 20. Then 3 into 7, that is 21. Okay, now 2 into 21, 42. Then add a 0. So after 20 seconds, they will use the same machine together. Hope all of you understood. Thank you.